Hello and welcome to everyone to this biomedical signal processing lab. In this class, we are going to learn about the RapidMiner software, which is mainly used for data mining and machine learning applications. So let's get started. After opening this software, it will direct us to a GUI page. I think it's taking some time. Okay, so uh, after clicking on this software, it will open up this GUI page. So for most of the advanced programming, we need this templates such as price risk prediction, then prediction maintenance, operationalizations. But for our usual use, we just need this blank process, or you can directly close this uh, window so that this page will come up. In the process panel, what we do, we just design our models and uh, using some of the blocks that has been provided by the RapidMiner software. In this case, there is a design panel in the top and a result panel, so you can switch in between this design and result uh, during uh, during designing of your process. You can just click on the design button, and you just design your model. Then after running your designed program, then you can see the results in the result section. So it is very handy. You can just within a click, you can just shift from design to result or result to design. The turbo pref and auto model, it is used for advanced processing, but right now we are just focusing on the simple process which is present right here. On the left side, you can see there is a panel called local repository. So it is used to store all your data during your processing. You can make a folder to store your project, or you can also use suppose for example, I have worked in many projects in RapidMiner, so I have created many folders. So if you want to create a new folder, you can just go uh, to this section. Then you can just create a subfolder. You can name it. Suppose I'm naming it as lab BSP. Okay. Let me do it again. It has just been created inside another folder, lab BSP. Okay, close. So first I have to delete this folder that I have created just right now. Yes. Then on the local repository, just create a folder, lab BSP. Click on OK. Okay, so my folder has been created. So here you can see there are many folders that I have been used during my projects. So once you save uh, your project, it will be stored in the local repository with a folder, and so that later if you want to again retrieve those data, you can do it through this local repository. In the below section, you can see another panel is there that is called operators. Under this panel, there is many subsections like data access, blending, cringing, modeling, scoring, validation, utility. So these uh, folder contain the operators that we can use during our project. Suppose I want to uh, read or write a, mm, a data set or a feature table. So uh, for those, uh, the reading and writing module will be I can the reading and writing module I can find from the data access folder. So let's see. This is you can see under the data access you have files, databases, application. To read and write files you have to again click on the files. Then for there is this another subfolder called read. So here you can see multiple options, and this is the best advantage of RapidMiner. It gives you the access to a large number of files like CSV, Excel with format, SPSS, statistical files, sparse file, and dbase file. So you can use this module to read. Suppose I want to read an CSV file, so I will just click in the read CSV, then I will drag it to the process window, then it will be created. So if I want to read an Excel file, so I will click on read Excel, then I will drag this and I will just lose it in the main window. So this read Excel module is created. So similarly, after doing your module, if you want to store your result, then you can do it through the write module. So under the write module, you can as present in the read module, you have write CSV, write Excel, write special format. So you can write your data, your result in all this format. Let me minimize it so that we can go to the next section. So similarly, the cleansing is used for data pre-processing, like normalization for missing values, for duplicate values, then dimensionality reduction, uh, and then the modeling is used for uh, the main process of your model is find out in the modeling sections. It contain your optimization, then time series prediction, then segmentation, correlations. Uh, all these operations can be achieved by using the operators present in the modeling section. Suppose I want to use a linear regression. So what I will do, I will go to the modeling section, then for prediction, then here you will find okay, you will find these sections like logistic regression. Inside the logistic regression, there is logistic regression, then logistic regression using SVM, then logistic regression using evolutionary method. Similarly, for neural network, there is four models is present like deep learning, then neural network, then auto MLP model. MLP stand for multi-layer perceptron, and in a similar way, there is seven model present under support vector machine, and these are the different category of support vector machine where there is a little bit change in the algorithm. So it will give you a vast, mm, a wider options while designing your model. Similarly, if I go for feature weight, so in the feature weight option, there is a large number of model you can find, like weight by information gain, then information gain ratio, by rule, by average, by deviation, correlation, chi-square statistic, Gini index, then tree importance, uncertainty, relief. So what is the use of this feature weight is after your feature set is ready, These models are used to assign some of the weight to each feature. Like they assign based on this weight, you will know how important is this feature is in the prediction of your data. So you can also use this feature weight option for evaluation of your model. We use normally this validation, then performance, then prediction. So we just learn about what are the panels present in the GUI page of the software. So one thing you can also see the help option. Uh, Whenever I will click on a operator, like right now I have clicked on the deep learning operator, so you can see in the help section it will provide all the details about the deep learning or the description of a model. So it will be very useful while you sometimes you don't know about how to use a model and what are the inputs you should give, how this model works. So these informations can be retrieved from the help section. Uh, for example, let's see for deep learning. If you go to the help section, it have uh, already given a descriptions about a deep learning and how it work. Its introduction, uh, then the input. What can be the input to a deep learning model? Then what can be an output? Uh, then parameter. What are the different parameters that is mm, that play an important role in the designing process, or the parameters you can change during your model. Here, for example, the parameter of deep learning are the activation functions, like 10s activation function, rectifier activation function, max out, uh, exp rectifier activation function. Then hidden layer sizes. What are the different what hidden layer sizes that will that signifies the number of Italian in your network model. And these parameters you can change during your model designing. So this is about the GUI panel we just see in the RapidMiner software. So another important thing is if you want to change this panel or this setting, you can do it by just clicking and dragging it to mm, anywhere. Suppose right now just I just drag the repository panel to the middle. If I don't want a operator panel, then I can also click on the cancel section, and I can cancel the operator panel. Like if I don't need this help panel, then again I can just cancel it. And if I need extra space for my uh, process, so I can also drag it like this. And suppose for at any time, if you want to go to the original setting, that you can do by clicking on the view, then restore the default view. It will just redirect you to the original look of your software like this. Another thing here is you can just click on file, and at any time you can create a new um, process, or you can go to the auto model section also, which will be discussed in a in after some time. Then you can browse the repository from this section. You can save your data. You can save your project by clicking on save. And after designing your model, you can just click on this button to run it, and the results will be shown in the results section. Now let's start with the processing after knowing the software. So for that, I just want to import a data that has already been created for this analysis. So for that, what I need to do, I have to click on import data. I have stored my data. Then I'm not using any data from the database. So I'm clicking on my computer. Then you have to give the path of the data you have where you have stored it. So for that, just let me go to this PC, then data, then lab, then here you can see I have a data set called sample feature. Then click on next. Then you will show you the data it contain inside this feature set. So it contain the information of your data, like I've used an Excel sheet, so it will showing the sheet number or sheet name. Since my data don't contain multiple sheet, then the sheet is by default sheet 1, and there is no other option in the sheet section. The cell range, you can see I have used my cell from A to K. That's why the cell range here is showing from A to K. And define header row. uh, yes, my first row is contain the header, that is the name of the features. That's why it has shown the header first row as my header row. So then I will go to next. So here you will get an option that to replace errors with missing values. If there is any error in your data set, it will be replaced by a missing value. But since all the cells in my data is properly uh, placed, there is no error, so it will there is no need to represent it with the missing values. So I will go for next. Then here you will ask where to store the data. Since I have already created a folder called lab bsp, so I will just click on lab bsp, and then I will go to finish. So it will my storing of data is now over. Let's spend some time on knowing our data set. So it contains total 400 rows, where each rows is uh, a single case. For a single uh, signal, we have calculated 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 features. So for each signal, we have calculated these values like arithmetic mean, median, summation, then variance, standard deviation, root mean square value, skewness, then kurtosis, then Shannon entropy, and log energy entropy. And the last column is the level. It is the class. That is, if I have 400 cases, so my first 200 cases belongs to group B, and my second 200 cases belong rest 200 cases belong to group A. So since the number of cases in each class is same, it is a balanced data set. So here you can see the first column signifies the row number, but it is not usually used during the process. We just use the number of features we consider in the data set. So as we know so far how to import a data set and how to see this data, uh, what uh, what are the different factor that is contained in the data set. So after the data has been imported, in the left panel there is two more options like statistic and visualization that we can also use for our data set. For suppose I will go for statistic, then it will show all the features I have used in my data that has been used in my data set, and it will give some of the important, some of the additional informations about my data. For example, for amplitude, it will give me the type of data, then the statistic. In the statistic section, it will give the minimum value of that mm, attribute in my data set, the maximum value of that attribute in my data set, and the average value. So suppose in case of summation, you can see the minimum value is minus 63.519, the maximum value is 50.825, and the average value is 0.396. If we click on the data, it will also give you an option for open visualization. If we click on this value, it will show you the histogram of this data set for amplitude, that is the amplitude value of different values of AM, then arithmetic mean, and then the frequency in the y-axis. So you can see this visualization only by clicking on the attribute. Similarly, if you go for the skewness, suppose I just click on it, then I will click on open visualization, then you can see the histogram of this attribute in the this visualization is totally based on your current data set. So if you want to go for more visualization except this histogram, then you can also click on the visualization section, where you can find in the left panel there is uh, a section called plot, which contain a subsection plot type. After clicking on this section, you have a large number of options that you can follow for your visualizations, like line plot, spline plot, scatter plot, scatter plot in 3D, then bar column, bar horizontal, heat map, then histogram, box plot, pie plot, range of the column, then range of the error bar, and many more. So you can use any type of visualization based on your requirement. So suppose for example I want to plot the 3D scatter plot. So I will click on the 3D scatter plot, then I will just go for the x-axis, what I need in the x-axis. So I will go for let arithmetic mean, then in the value of the columns, that is y-axis, is let I will take median. So then my scatter plot is ready for a 3D. In case of 3D scatter plot, it will plot the values of three different attribute. Here in this example we have arithmetic mean, then skewness, and median. If you want, the scatter plot is used to see how uh, one of the attribute is changing based on the other in reference to some other attribute. So if you want to plot a 2D scatter plot, I will click only on the scatter, and then I have to choose two different attribute values. Here by default it has been uh, uh, selected that skewness uh, and skewness. Okay, so we have to change the value, suppose amplitude, and here let it amplitude. Skewness I don't need, so I have to apply this value, and you can see. Acha, okay, sorry, I have chose amplitude in both the section. So let I want to see how the arithmetic mean changes with the RMS. Apply. So see here in my x-axis it is amplitude, not amplitude, is arithmetic mean. Sorry, maybe I am saying amplitude in most of the cases, but it is sorry for the mistake. It is arithmetic mean. So arithmetic mean in the x-axis and root mean square value in the y-axis. So here how you can see how the arithmetic mean value is changing with respect to the RMS. You can also change the x-axis, y-axis, title, legend. There is the option, the normal options that we need for a uh, the plot. So suppose let's go for another example like box plot. For box plot for RMS, so you can see if you click on the box, it will show you the maximum value, the upper quartile value, the median value, the lower quartile value, and the minimum value. Similarly, if you go for, let's say, a pie, not pie chart, a bar column chart. So here you can see this. This is somehow like the scatter plot. Here the x-axis is arithmetic mean, and the y-axis it is root mean square value. So there are many other options you can go through according to your requirement, and this is all about importing a data and then knowing more about its statistic and then visualizing this data in RapidMiner. Now let's move to the design section to build our fast model. For that, what I will do, I will just drag the sample feature that I have already imported from my computer, and for this class we are going to use this feature set only. So let me just drag this uh, data, and then I will just connect this output to the result section. So if I will say that I have already created a model right now, and the work of this model is just to show you the data set that have been retrieved from your repository. So in the right side, you can see there is a RES result section. So whatever you will connect with this, connect it with a line, it will show you that the output of that point as your result. So if I will run this model as then in the result section, you can see the whole data set that has been retrieved. So how we can do that? I've already told you, for running a model in the RapidMiner, you have to use this button on the top that looks like a play button or a blue triangular button, you can say. So just let me click it on here, and just you can see after clicking it, the design panel is just shifted to the result panel, and we can see the result as the data set we have just imported in the uh, repository. To go back to the design section, I can just click on the design, and whatever uh, operator or modification to my process I can do in this section. Now let's go for some advanced model. So as we have seen that we have already imported a data set. We have already know about the feature that contain in the data set, the number of attributes, then the classes. And now let me, if I want to build the correlation matrix between uh, my attributes of the data set, then how I can do that? For that, I have to go for the utility, then maybe, okay, let me process control. No, this is not in the process control. Uh, okay, suppose you don't know where to find a operator. So for this kind of problem, right now we are facing that when selecting a model or operator, you have to search for each and every file locations or folders. Uh, this is a tedious task. So if you know about your operator, then you can directly search on the search engine provided in the operator panel. And so let me search correlation. Okay, so you can see just in the modeling sections, we just found out the correlation that contain different type of correlations uh, functions or operators. So I will choose the matrix of correlation matrix operator. So just click or drag here, or you can also do, let me show you, you can also just double click on the correlation matrix, and it will be shown on the process window like this. So in the correlation, there is in the if you want to know more about the correlation, then again we can use the help section, and we can see. Let me make the help section a little wider so that it will be visible easily. So description. So you can see here the description of the correlation. It is given: a correlation is a number between -1 and +1 that measures the degree of association between two attributes. A positive value of the correlation implies a positive associations. In this case, large values of x tend to be associated with large value of y, and the small value of x tend to be associated with a small value of y. So what we understood is the correlations signifies the association between two attributes in the data set, and uh, the matrix correlation matrix show you the association between each attribute in the data set with respect to each attribute on the data set. When we will see the matrix, you can understand better. So for right now, just see the correlation matrix operator contain an input uh, value or an input port that shows. Right now there is we didn't have connected it to anything, so it is showing an error that mandatory input missing at the port correlation. So this red symbol is always signifies the mandatory input. So what we need to do is the input data of output of your retrieved data is just connected to the input of the correlation matrix, and then there is in the output sections there is three output. So right now we are just more uh, we are just more into the metrics of the correlation matrix. So I will only just connect the matrix output to the our result sections. Now I can just okay, the attribute filter type in the right hand side there is it will show some of the settings, so you can choose different type of settings for your correlation. That is here the default setting is the normalized weight. So for right now we are just going for the default setting. So again uh, as we know, to run a program in our RapidMiner, just click on the blue button and your correlation matrix is created. So what I have told, it will just give you the associations of all the attribute with all other attribute. Suppose AM with AM, since these two attributes is same, so this association is always 1. So in the diagonal section, you will always get a 1 value, and for AM with the median, your correlation value is 0.072, and for arithmetic mean and summation, your correlation is 1. So normally what we do, we just discard the attributes. If two attributes have the association 1, then there is no need to take both the attribute. We just what we do, we just discard one of these attribute. So in this result sections, we also have some of other options with our results. So let's check what are those. Pairwise table. So the values that we have already seen uh, in the matrix format, here it will show in the tabular format. Suppose for the first attribute amplitude, it will uh, display all the correlation value of this AM value with all other attribute. For example, AM with median, then with summation, then with variance, then with standard deviation, then with RMS, and so on. Similarly, after that, for median, it will check all the combinations of attribute, then for summation, and so on. Let's see the matrix visualization sections, what we have in this section on the result. So it is okay, it is more like a plot, uh, a color plot, where the color of each sections symbolizes your value. Like it will the value of the correlation matrix changes from -1 to 1, and for 1 the color is red, and for -1 the color is dark blue. So you can the from the color of each cell, you can just can see uh, its correlation value. For example, the AM and LEE, we have seen the correlation is -0.182, and its color ranges somewhere between 0.182, so it's a little bit yellowish, or maybe a little bit greenish. Sorry, it is a -0.182, so it's a little bit, it's tending towards to a greenish color. So this is all about correlation. So let's move to our design section once again, so that we can go for some other operations. Now, as we have built our first model that find the correlation matrix of your input data set, now let's see how to save this process. To save this process, we can go to File. Then here you see two options like Save Process and Save Process As. So I will go for Save Process As, and then I will select my folder that I have created in my repository, that is lab BSP. So inside this folder, I will save the process as, since uh, it, uh, uh, this model is used for a correlation matrix. So I will save it as like correlation mat. Then I will click OK, and my process will be stored in the folder. You can also see this is CORR, core matrix. So now let's move to build a process, build a model for simple linear regression. In this class, we will go through 2 or 3 simple model classification model design. Then you can uh, practice a lot of model present in this section according to your own. So let's get started. The first step of designing a linear regression is obviously retrieving the data that we have already retrieved in the retrieve here. Then in this case, for simple linear regression, we are not going to include all the attributes. So we will select some of the attribute for the prediction purpose. For that, what we will do, we will select the select attribute operator. So here you can see it have an input. So we will connect the output of our retrieved data to the select attribute option. Then I will double click on it. Then here there is an option attribute filter type, all, the single, subset, or so I will choose a subset of attribute, and then it will give an options the number of attribute you can select. So just click on select attribute. Then suppose I will taking kurtosis, then skewness, then root mean square, these 3 value. For now you can choose other value or all attributes also, there will not be any problem. Then apply. Okay, so after selecting this attribute, the next step is so we have selected our attribute. In the next step, what we have to do is to set the role I will connect this with the previous one, the target. Okay, since I think I haven't selected the level value, so let's select the level also in the selection attribute, apply. Then now if we go, then click on level, then take it as a okay. So this is all set. So here if you want to do some pre-processing. Then this is the step where you most of the pre-processing was done. Suppose you have in your data set you have some missing value, then uh, you can replace this missing value, or uh, suppose in some of the cases you have not all the numerical data types, and there are some of the data types that is in the categorical. So you can also change the categorical uh, to numerical value. For that you can select the nominal to numerical operator, and then you can change that attribute to a numerical form. Since logistic regression, for logistic regression, all the input must be in numerical, and in our data set, all the attributes we consider are already in numerical form, so we don't need to go for any pre-processing. So in the next step, what we have to do, we have to split the data into train and test. For that, you have to choose split data. Then let me connect. Then here you will ask for a ratio. So let me take 0.7. It means 70% is for training and 3% is for testing. Okay. So what is the training and testing means? Whenever we are going to design a machine learning model, what we do, we just give some of the input and output as an example to the machine. Then uh, this machine learning algorithm, what it do is just analyze this input and output, and it make a relation between these two and try to understand the correlation between these attributes with the output, and uh, that correlation will be applied for the test data set. Whenever we will give a new input without giving the output, so it try to predict based on its prior uh, acquired knowledge. So this is about test and train. In some of the cases there is also validation, in which a certain amount of data is taken for validating the machine learning model. So let's move to our model section. So I think we have to add another thing here. It is not only 0.7%, we have to add 0.3. We have to make two partition, one for the 70% going consisting of the first partition, and the rest 30% will be the second partition. Then okay. Then now our model logistic regression, or for that the first partition value come to the first partition value went to the 70% of the data went to our model, and it will try to learn from the 70% of data. Then in the second part we have to take apply model. Here it is. The second partition will went to apply model, and then to calculate the performance of the operator we have a performance module where the level will go as the output, and here okay, I think it's done. So let's run this program and let's see. The value of the parameter partition must be numerical. Was more info. Got it. Okay, I guess the uh, problem is due to the level, since the level is in our categorical form, so we have to change it to numerical, I guess. So for that, again, we have to take the select attribute and then choose here, then attribute type single, then the level attribute, and then nominal to numerical data. Okay, so here we have to first change our level to numerical. For that, just click connect the set role output to the nominal to numerical, where we have to choose the attribute filter type as single, and then we have to choose the attribute level, and it will change the level attribute to a numerical form. After that, the output will be connected to select attribute, where we have to choose we can you can go for subset and then select all three attribute kurtosis, RMS, and SKW. This is for the independent attribute, and level is a dependent attribute. So here we have to choose the independent attribute. You can go for kurtosis, RMS, then skew, then apply, or there is another way. You can go for single and you choose the level, and you will click the inverse selection, where inverse selection means it will choose all the attribute except this one. It means in leaving the level attribute, it will select all other attribute present in the sub attribute set. So after that, just connect the output to the split data. We have already splitted this value into 70 and 30%, where 70% is used for training and 30% used for testing. Okay, so the training data set will be connected to our model, that is logistic regression, and the test data set will be connected to the apply model. And then for performance evaluation, we will connect the output of the apply model to the performance module, where the performance it will calculate is accuracy, or you can choose multiple value, accuracy as well as classification error, and there is more other options. If you want to calculate root mean square error, normalize absolute error, then anything you can calculate based on the option you choose. And then the final section is to run our model. For that, it is very simple. Just click on the play like blue color button, or you can also okay, in the result section we just got our output, that is we taken two class, that is class B and class A, and here we got the accuracy of 58.33% in our logistic regression, which is not uh, uh, very good classification accuracy, but this is only for our understanding. And then we have, since I have selected accuracy, then classification error, then root mean square error, it is showing three different options in the criterion sections. So classification error is 41.67%, then root mean square error is 0.499, plus and minus 0.000. It means uh, it will give you a root mean square error with a standard deviation of 0. So in the left hand side, there is some other options like performance, description, and annotations. Let's go to description. Let's see what is the what inside it. So it will show you the confusion matrix. Uh, Using the confusion matrix, you can calculate many other parameters such as precision, then recall, uh, area under the curve, and that's all. So here let's go back to design, and since we have seen how to design a simple linear regression model using RapidMiner. So next we will move to another model called, okay, in logistic regression also there is 2 or 3 model. Let's see how they will work, because in this case we don't have to change many things. I think we just have to replace this model with this new model. Again, parameter training, mode apply model. Let's see what inside. Okay, so this is the logistic regression SVM. So let's see whether it is working or not. Again, just run. Okay, so the accuracy is 45.83%, and our classification error is 54.17, and root mean square is 0.513%. So if you want to include some of more performance measure except these 3, so you can choose here, let me choose the absolute error, then normalized absolute error, then logistic loss, for example. So when you will again run this one, then it will show you all these parameter in your result section. So let's run again. Okay, see, in the criterion section, previously it was only 3 performance measures, now it is 6, and it will showing all the all the values. Then in the description sections, again it will showing the confusion matrix. So here we have seen the logistic regression model. If you want to go for the linear regression, then I can select search for the linear regression module, and I will just drag it, and I will just delete the logistic regression, and then I will connect it, this one, and then I will just run the output. So this is the output of our linear regression. It is 58.33. That is more than, I guess, the logistic regression one. So another thing I want to include is, if you want to see the actual value and the predicted value by uh, of the model, then you can just click on the example, and you have to connect it to the result sections. Again, for the apply model, that is the for the training data, you can also see this result. And here the number of tab in the result section uh, will be equal to the number of tab it will show uh, in the output of your model uh, in the result. So if I will now run this program, so see the number of tab it will produces performance vector, then example set and example set of apply model. So let's see for performance vector performance we have already seen prior, and let's first go for the example cell for apply model. So here it will show you the actual level of the data and then the predicted value. So in some of the cases you can see the actual data was belong to class B, but our model have predicted it as a class A in most of the cases. So this is error. In similarly, the example set of the sample feature, it will show you the data set that has been taken as input to the model. And in the performance in the linear regression model, it will show you the uh, attribute we have taken and then the detail of this attribute and the p-value, statistical and p-values. So this is all about linear regression and logistic regression. Okay, now let's see how to build a decision tree model. So for that, let me first save our previous process. I will name it as something um, related to linear, suppose reg, linear regression, maybe in full form. Okay, then we will go for a new process, blank. So let's first retrieve our sample feature, and then as we know, after this we have to just select attribute. For that, click here, then we have to select the role, set role maybe. Okay, set role, just click. So here in the select attribute, go to subset, then just choose. In this case, maybe I will take kurtosis, median, skewness, and then variance and level. Let's take this much value for now, then apply, then set role. The role of just select level attribute, it will act as a level. In this case, our role is just set. Then take the decision tree. Okay, here we will see under the trees, predictive, under the trees we have the decision tree model. Just take it here, just connect it. So here you can see in the decision tree, so let me tell you about what is a decision tree. A decision tree works on a recursive partitioning. In that case, what happen, it will divide your data set into two groups based on some predefined conditions, and those conditions can be used based on these criteria like gain ratio, information gain, Gini index, accuracy. If you go for the decision tree theory, then you will know better. But for right now, we are concentrating on how to build a decision tree model. So for simplicity, let's stick to the default parameters. Uh, Here, the criterion is about gain ratio, and other parameters are maximum depth, and then minimum gain, minimum leap size. The leap size also play an important role in the accuracy of the decision tree. If it will be very small value, then it may overfit the accuracy. So that's why, since we are not sure about the leaf size in our attributes, we are sticking for right now we are sticking to the default parameters. And then um, the after that we have to take the, oh sorry, I haven't split the data. So split data, okay, we have to choose this model. Then we have to add two entry, one for training, that is 0.7 70%, one for testing, that is 0.3 3%, sorry 30%. So you can, it is not mandatory that you should take 70 and 80. You can take 17 and 30. You can take 0.8 and 0.2 also, or 0.75 0.25 also. So let's set it okay. Then just take it in this place, then connect to it, then apply model. And then the performance. The decision tree can be used for regression as well as classification problem, but in this case we are just sticking to the classification. We are not going to the regression right now. So just take the training data to apply model, then the output of the test, our model parameter selected model, then performance, then result. I think we have just built our model. Let's run it. Oh sorry, we have to choose the performance parameter that we want to display in the result. So for this I will choose accuracy, classification error, then relative error maybe. It depends upon your requirement. Then maybe cross entropy, let's see. So you can choose any parameter, any classification parameter, or any number of classification parameter. RapidMiner have the provision to uh, select more than one classification parameter, so you can use it. There is uh, not a big issue in that. So let's go for running this model. Yeah, we just did it. So here the classification accuracy is 56.67%, then classification error, relative error, and cross entropy value. So in the description sections we will get, as we know, it will show you the confusion matrix, and then design. If you want to see the predicted value and the uh, true value, then you can choose this example. And if you want to see the model parameters, then you can select here also. And again, if you run, then it will show you these values. So here you can see the actual level, the predicted level by the decision tree, and then in the statistic Okay, this examples. Okay, yes. So in the uh, model parameters, you can see it will show you that the decision tree it have built for your prediction. It will show you this value and the threshold that has been taken in each splitting. So if you go for the description, it will show you the algorithm also, and for graph, and here there is a different option for your tree visualization. So if I'll choose radial balloon, there's different layout for the visualization of this graph, but let's stick to the default one. And here the option for node levels and edge levels, so you can also select or deselect it. So here we come back to our process, and we have successfully built a decision tree classification model for our data. So similarly, since we have already seen the section of trees, so let's go for some of the other uh, model it have. So if I want to go for random forest, then I think I just need to uh, just replace this model with the random forest parameter. So let's see whether it is working or not. As I have told, the RapidMiner is very user friendly. Only you just have to know the steps and the name of this model parameters, then it will be very easy. Like suppose in a classification problem, first I know that I have to retrieve the data. So the name of the uh, operator is also here retrieve sample. Then I have to select select the attribute. Then here the name is select attribute. Then I have to set the roles of the attribute. So it is very user friendly. It will you don't have to mug up some of the operator names. You just search here and you will find your uh, useful operator very easily. So let's see whether this random forest model is going to work or not. And before that, let's have a look on the parameters it have. It have the number of trees, then criterion again you can choose grain ratio, information gain, Gini index, accuracy, and least square values. Then maximum depth is 10, since and this parameters can be optimized using an optimization operator. And for since right now we are just concentrating on building some of the simple models, so we are not going for this optimization process. We will look into it later. So let's run. Okay, so we got our performance as 74.17. So you must be thinking, why random forest giving you a high accuracy? So this is because the random forest consisting of a voting concept. It will build off a number of models, and then it will take a vote from in the individual model, and then the highest and based on the number of votes, and based on the number of votes, the final output is depend. So that's why uh, the random forest model is it show a better performance than most of the cases. It show a better performance than the decision tree model. So again, since we are going through all these trees parameter, let's also check the gradient boosted tree, how to do it. So I think again I just have to change this parameter, sorry, this operator here, and just select these values and then run. Okay, this is very much simple. So in this case we can see it is showing 70% classification accuracy, and in the description section this is the uh, confusion matrix. And then again on the result section and the gradient boosted tree, since a gradient boosted tree also is depend upon a number of trees. So here in the description of this model, you can see it has built a total number of 100 trees, and based on all these results, your final result will depend. So up to now uh, we have uh, we have seen the logistic regression, then linear regression, then decision tree, then random forest, then gradient boosted tree. I am not saving all the processes individually, uh, but you can do as it your own, um, because in this case the main thing is knowing the template of your classification model. The changing a classification operator or model is not that a big issue, but you have to just remember what are the steps in this classification process. Okay, now let's see how to design a SVM classifier. So till now what I have done, just let me save this process. So save process as, so it is based on tree based model, so I will just give a similar name, tree based maybe, then okay. So let's take a new process. Since the all these things up to this much is common, I'm just copy it, then new process, blank, then I will just paste it. Okay, I don't know why it is so much expanded, so let's stretch it. Okay, so our first, as I am repeatedly telling, your first step is you're inputting the data or the feature set, then selecting the attributes that you going to use to train these models, and then set the role. This is for the independent and dependent variables. Your dependent variables is always your issue level, or the class in this case, or the independent variables are the attributes, and the value of your class is always depend on these independent attributes. Then split data. This is used for the training and testing purpose. In most of the cases, we go for 70% training and 30% testing. Okay, then in the next step, to take the neural network, okay, for there is a options in a folder in the modeling section is sub folder is predictive modeling, and then inside that the neural net, four neural net model is there. One is neural network, auto MLP, and deep learning and perceptron. So right now let's first go to the deep neural network process. In this case what we do, we have to connect our splitted the test data with the neural net. Then for the training data set, we have to apply the model. We have to apply model. Just let me connect the test data with the apply model, then the output of, okay, I have done the wrong connection. Oh, then this model to this model, and then for performance evaluation, just select the performance classification, and then select the level with the level, and then the performance. Oh god. And the performance will be connected to the result. Okay, let's check. Let's for neural network, let's select more number of attributes in this case, because we have already uh, seen the model performance for 3 or 4 attributes. So in this case, let's select 1, 2, 3, 4, 5, 6, 7, 7 attributes for this case, and then I think our model is ready. We have to just run it. So I will just click this button, and my neural network is ready. So it will showing 73.33% accuracy, which is a very good uh, as compared to our previous accuracy in linear regression and logistic regression. This is quite good. So again, in the description sections, we will see the confusion matrix, and if you want to see the examples, you can connect this example with the result, and this if you want to see the model parameter, then we can see the model with the result, and then again we have to run it, and you can see the neural network is the created neural network is seen here, and the description we will see for node 1, node 2, node 3, node 4, 5, 6, and here we will see the output for class B and class A. So I just assuming then you have some of the idea about this uh, classification models, some of the basic idea about the classification model. And if you want to, we can see the parameters of the neural network. Then it have the learning rate, momentum, error epsilon, and hidden layers. So in this case, the number of hidden layers is hidden layer size is 2. If I will change this to 3, then it will build a model that have unnamed expression will be lost. Okay, apply. Oh, I don't know why it is not hidden layer name, maybe third. So let's see how it is working. Hidden one. Okay. So our neural network is ready. So let's move to your deep neural network. So here we will select neural, and it is showing the deep learning. I think if we just have to replace this model in the training and then connect, we have to make the connections that has been lost. And okay, I think it's ready. Just to let's see what are the parameters in this case. Here we have activation function. So there is a number of option for your activation function, that is 10s, rectifier, and many other, and hidden layer sizes, then a number of epoch, then compute variable importance. Okay, uh, so now we can run this parameter. Okay, so our model is ready and it is showing 51.67% of accuracy. So if we'll go for the deep learning model, uh, you can see the details of this model here, and then again design. So similarly, we can let me save it first. Save process as maybe new. I can neural net. mm, okay, I think the tree based model has been saved somewhere else. Okay, not an issue. We can retrieve it from our local repository. So let's go to another process, new process, and as to save time, we are not again dragging and taking this initial operators. So I will just choose it from here. For neural network, maybe I will just copy, Control C, and paste here. Okay, and then now let's see how the support vector machine works. Here also many options of the support vector machine. These are there is some of the difference in the algorithm of the support vector machine. However, the main idea is remains same. So let's connect it, then apply model. Okay, then just connect the train data set, then performance. We are taking the classification as the performance classification accuracy as the performance measure. In this case, sorry, I have connected is wrong. Okay, now it's done. So let's run it. Okay, so our accuracy is 64%. If you want to, again I'm saying the performance measures, if you want to include some of the other parameters as your to measure your classification performance, so you can choose many other options available in the RapidMiner, and let's run it to see how. So in the criteria section, all the measures you have chose will be seen here. You have to just click in here and you will see the output of this value or the result in this value. So again, descriptions of this support vector machine, here it will show the confusion matrix. Okay, so another thing is since here we are selecting the attributes of different model, but suppose we don't know how to select those attribute. For up to now we are just selecting those attribute in a random manner. We have no idea how these attributes are contributing to your classification performance or the classification model. So there are a number of methods from which you can a weight will be assigned to your attribute, and based on those weights you can know that what weight a attribute carry in the process of classification. So from that you can it will be easier to choose your features wisely, because because the subset of feature you choose play an important role in the classification process. So in the now we will going to see how to measure these uh, weights of an attribute. So let me take another, let me first copy this, and then I'm not saving this because here there is not much changes is there. You have to just change your classification model, and rest of the thing is almost same in your template. So I will take a blank process. No, I will not save. Then paste. Okay, so here what we have done, we have just retrieve our data. Then we have selected the attributes and set the role, because you have to select the level, which is the dependent variable and which is the independent variable in the classification. And so here just we just want to in this case we just want to uh, calculate the weight of different attributes present in our classification, sorry, in our data set. So that we can do by selecting weight. No, I think it's feature weight. Okay, so you can see in the modeling section there is a feature with subfolder, and it contains 17 different types of operators. So you can use any of these operator uh, to calculate your weight. So how it will work, just what it does, it will take every single attribute and it will calculate the accuracy of the model, and then it will assign some of the then it will assign a weight to a single attribute based on a criteria. So in weight by information gain, the assigning of weight is based on the information gain value. So after setting the role, just connect it to weight by information, then just connect the weight to the result. And now I will, let's run it. Okay, so in our output we just see it will display all the attribute I have selected, and it will assign some of the weights based on the information gain. In the left side of the result section there is also a subsection called weight visualization. So let's see what is inside it. So here you can see a visualization chart is given in this software, where the x-axis contains the attributes and the y-axis contains the weights. If you are worried about how these weights are working and how this what is the logic behind this classification models, um, then you can follow a paper published in our lab. The link will be given in this section. You can go through that and you can have a basic idea about this classification model and and these weighting methods. And if you have any doubt, then we can also discuss later. Since we are just focusing on the building of this model, we are not going through the details theory of this classification model and their mechanism. So this was about the weight by information gain method. So now let me do a combined program where a multiple number of weighting method can be used to find out the weights of the attribute in different weighting methods. So for that, what we have to do, just take just go to feature weight and just select some of the weight based method. Suppose for this case, let me take information gain, then weight by information gain ratio, then let weight by correlation, weight by chi-square statistics, then weight by Gini index. This 5 method is enough. If you want to know more about this weighting based method, then just click on the operator, and here in the help section you can see its description how it operates. For example, let's consider the case of Gini index. So here in the description it is written, the weight by Gini index operator calculates the weight of attribute with respect to the level attribute, that is your class value, by computing the Gini index of the class distribution. If the given example set would have been split according to the attribute, Gini index is a measure of impurity of an example set. So in this way, a little description is given for each of the weighting method. And as I have already told you, for more information, you can refer to one of our uh, paper. So let's come back to our design. Let me connect this with all the weighting method. Oh, it is not happening. So I think we need a multiplier or a operator that can produce the multiple input. So for that, there is an operator in RapidMiner. I guess it is multiply. Let me check it first. If you connect with this output, then okay, yes it is. So you can see as soon as I connect one output to one weighting method, another output port is generated automatically. So let me connect it with everyone, and then the input will be connected to the set role output. Here for selection of the attribute, we have choose all attribute. For set the role, we have to choose the level, and then it is done. Okay, now we can connect the weight value to the result. Each of the weight value weight by information gain. Okay, okay, each of the weight value to the output or result. Okay, Now let's run this piece of code or model. Input example cell does not have a level attribute. Okay, so let's click on more info. So it is saying uh, you can use the set rule operator. I think we haven't set the level in the set rule. Yes, the target rule not in regular, it must be in level. So now let's run it again. Okay, we got it. So you can see we have taken 5 different type of weighting method, and we are getting the weights in each of the cases. This is for information gain ratio, for chi-square statistic, then by correlation, and by Gini index. So you can also visualize these values using some bar chart at, as we have seen in case of the information gain in the prior case. So in this case, in every for each of the weighting method, you can visualize it, or you can see the weight and these attributes. So let me save this process as feature weight. Okay. So let's move to another important option in this RapidMiner software, that is the auto model. So auto model is used for advanced processing, and what it do is it will take a large number of inbuilt model and check uh, the performance of those model on your data set automatically, and it will suggest the best models. So let's click on auto model. Oh, I think my license has been expired from. Okay, no problem. We can go through this auto model in some later time or in some another class. Uh, so we still have some time left. So let's move to feature selection. So why feature selection is important? Because uh, in your machine learning model, what happened? The feature you are providing, all the feature not contribute equally to your to the performance of your classification model. So for that case, what happened? It is very much necessary to discard those features which is not that much important for our model. So for that discardation, we use the feature selection method. So here different feature selection method is available in RapidMiner. You can just search feature selection and it will show you a number of options. But before going to the details, let me uh, erase this. Okay, let me delete these values. Okay, these three operator we need, I think. Okay, so in case of feature selection, there is a lot of option. That is optimization selection, forward selection, backward selection, then optimize selection in brute force, optimize selection using weight guided method, then optimize selection using evolutionary method. So we will first look on the forward and backward selection. So just let me drag this out. Let me connect this here and then the output to the result. So before going to the forward selection, let me tell you how it works. What it will do, it will first consider one attribute, then it will calculate the model performance, and then it will add another attribute, and again it will calculate the model performance. And if after addition of an extra attribute, if there is no significant changes or improvement in the model performance, the second attribute will be discarded. Then another attribute will be added, and again the same process continues. So here what happens, if a attribute is contributing significantly to the improvement of the performance of the model, then it will be stay, otherwise it will be discarded. So how it will work? It will work based on a classification model. So if you go inside the feature selection, what we need to do here is we have to just split the data here. Okay, just connect it, then double click on split data, add to entry. We have already did this number of times, so I will not invest much time in this. Okay, then our model. So let me take a random forest model for this case. Okay, let me search random forest. Okay, we got it. Random forest model. Just select here. Then we have to take apply model. Then the performance. Then we connect the level. Then it will connect to the output. I think it's done. So what the forward selection will do, it will take a single attribute, then it will calculate the performance based on the random forest model, and then it will add another attribute. Again it will calculate the performance, and based on the improvisation of this classification of performance, it will decide whether to take the second attribute or not. So let's go back to our initial design, and then it's time to run this model. So since forward selection works on a number of combinations, and so based on your number of attributes, it will take a few extra moment. So we got our results. So okay, okay, so I think I haven't connected. Okay, I have just connected the example with the result. That's why we are seeing the example set. But let's connect the attribute with the result so that we can see the weights. So let's run it again. Okay, so here we saw a list of attribute and the weight. So in case of feature selection, if the weight is either 0 or 1, so here 0 signifies the attribute is discarded, and 1 signifies the attribute is considered or recommended by the feature selection method. So in this case, three attributes, variance, Shannon entropy, and log energy entropy is suggested by this forward selection method. And we can also see, go for the weight visualization, where you can see these three attribute have a value 1 and rest of the attribute have a value 0. So let's go back to design. Now our forward feature selection method is ready. Now what we can do, we can check for the backward selection. So for this, let me delete this model. Now choose backward, sorry, it's not backward selection, this is backward elimination. Okay, so let's connect it. Okay, connect the example with the result, then connect the attribute with the result. And okay, so before going to the backward elimination, let me tell you how it works. So in this case, what happened, this is a little bit opposite in working to that of the forward selection. In this case, what happened, at first it will take all the attributes in the feature set, then it will eliminate one of the attribute, then again it will calculate the performance. If elimination of an attribute does not significantly changing the performance or lowering the performance, then that will be eliminated and rest of the feature is considered. And the same process continues in the second round. Another attribute will be just discarded and the performance is calculated. If it is not significantly decaying the performance of the model, then it will just eliminate it and the process goes on. So again inside this we have to do the same process, that is split data, then just connect it, add to entry, 0.7 for training, 0.3 for testing, then OK. Then after splitting it will okay our model. So for this case let me take the SVM model, just connect it, the training. For testing we have apply model, just connect the training set here, then the model output, okay sorry, the training will be connected to the unlabeled input. And then here, oh, performance I forgot, so let's take the performance, and then connected it with the result. So our backward elimination method is also ready. So let's run this program and let's see what is the result. So it will take some time. So in this case what happened, it has discarded only the skewness and it kept all other attributes. For visualization you can go for, you can click on the weight visualization and you can see except skew all other attribute values are 1. So similarly as there is not much change in the process, I will not go for all the elimination method here. You can see here in the feature selection, sorry, in the feature selection there are 1 2 3 6 type of feature selection method. So let's go another one, brute force. But before, let me tell you the description how is it works. So here it is written, the optimized selection operator is a nested operator, that is it has a sub process. This sub process must always return a performance vector. This operator select the feature set with the best performance vector. You need to have basic understanding of sub processes in order to apply this operator. Okay, so it just develop a sub process, and then uh, it will compare all possible combinations of the feature set. So this is I think somehow a lengthy process, because we are not taking the attribute one by one, or we are not e eliminating the attribute one by one, but we are considering all the possible combinations of the attributes. So let's see. For this again, split data, then model. Let me take the random forest here. Again, so connect it. For we have to take two entries for training and testing. Okay, then apply model. Just connect the test data with the unlabeled input of the apply model, then the output of the model classification model through the model input. Then okay, performance we have to calculate also. For performance we are considering the classification performance. That's all. So let me go back to the process and let me run this program. So it will take some time, and maybe uh, a much more time from the forward and backward elimination, because it will check all possible combinations of the subset of the feature set. Sorry. So let's wait here. Till that time, let's have a look on the different operators present in this RapidMiner software. So we have already discussed about data access and cleansing. I have already told you about this is mainly used for data preprocessing and some of the dimensionality reduction section. So let's check on validation. In the validation, there is performance section. In the performance, we have predictive section. In the prediction section, there is 7 type of performance evaluation method. That is for classification, for binary classification. Whenever you are dealing with a regression problem, you can use the regression performance. Then ranking, support vector count, attribute count. Okay, then for segmentation we have cluster count performance, cluster density, then distance, then distribution performance. And for significance test we have t-test and ANOVA test. So you can see most of the uh, methods or procedure we are using in our uh, data mining or a classification problem that is available in this RapidMiner software, and it is very user friendly. On only you have to just click on, only you have to just know how to choose a operator or a model, and just you just have an idea about what to give as an input to the model and what is the possible output from that model. So you can see it is taking much more time, as A large number of possible combination of subset is evaluating evaluated in this method. Okay, so you can see the best possible combinations got is arithmetic mean, median, then standard deviation, and LEE. And all other attributes it has given a 0 value. So you can check, go for the visualization where this 4 attribute have a value 1 and rest of the attribute have a value 0. So this is all about today's class. So let me give you a brief summary of this class. So what we learned from this class today, we first get to know how to import a data file, or how to access files in RapidMiner, then how to store data, how to make your own folder in the repository where you can easily store your data set or processes. And then we knew some of the simple machine learning model like logistic regression, linear regression, then support vector machine, decision tree, and many more. And some of the network neural network model like deep learning and then neural net. And then we knew about the weighting methods and how the attributes how the weights of the attributes can be calculated using different methods. And then we have also seen the feature selection method where you have to select a subset of feature out of all the features that will give the best performance to your selected model. So today we are unable to go to the auto model section, but in some of our upcoming classes we will go through it briefly. So thank you all, and I hope now you can able to make your own model. If I will give we will give some of the problems to you and the feature set will be given, and then you have to find out the performance, or you have to find out the weights. Then you can also go for the feature selection according to the question that has been given to you. So thank you.